Welcome to Lesson 6 of our Chemistry from Zero to Hero series. Today we're shrinking down to explore the incredible world of atoms and molecules, the fundamental building blocks that make up everything in the universe. From the air you breathe to the device you're using right now, everything is made of these tiny particles. Atoms are so small that one drop of water contains about 1.7 sextillion atoms. If an atom were the size of a marble, a human hair would be thicker than a football field. Let's discover how these invisible pieces create the visible world around us. Let's explore what atoms really are. An atom is the smallest unit of an element that maintains the properties of that element. Every atom consists of a tiny, dense nucleus surrounded by a cloud of electrons. The nucleus contains protons with positive charge and neutrons with no charge, while electrons with negative charge orbit around. Protons determine the element's identity, neutrons affect isotopes and stability, and electrons control chemical behavior. Remember that atomic number equals proton number, mass number equals protons plus neutrons, isotopes are same element with different neutrons, and ions are charged atoms. Most of an atom is actually empty space. Now let's understand molecules, teams of atoms working together. A molecule is a group of two or more atoms held together by chemical bonds. Molecules can be made of the same type of atoms like O2 oxygen or different atoms like H2O water. When atoms form molecules, they create new substances with properties different from the individual atoms. We have diatomic molecules like O2 and N2, polyatomic molecules like O3 ozone, compound molecules like H2O and CO2, organic molecules based on carbon, and macromolecules like DNA and proteins. Molecular formulas like H2O and CO2 tell us exactly what atoms are in each molecule. Our understanding of atoms didn't happen overnight, it took centuries of brilliant minds. Democritus first proposed atoms in 400 BCE, John Dalton developed the first scientific atomic theory in 1803, J.J. Thomson discovered electrons in 1897, Ernest Rutherford discovered the nucleus in 1911 through his famous gold foil experiment, Niels Bohr proposed electron shells in 1913, and modern quantum theory developed in the 1920s. Each scientist built on previous work, with famous experiments like Dalton's law of definite proportions, Thomson's cathode ray tube, and Rutherford's gold foil that showed most atoms are empty space with a tiny, dense nucleus. Atoms and molecules aren't just abstract concepts, they're everywhere in our daily lives. Water is H2O with 2 hydrogen and 1 oxygen atom, salt is NaCl with sodium and chlorine ions, sugar is C12H22O12 with 12 carbon, 22 hydrogen and 11 oxygen atoms, and oxygen gas is O2. Your body is made of atoms too, about 65% oxygen, 18% carbon, 10% hydrogen, 3% nitrogen, and smaller amounts of other elements. The properties of materials come from their atomic structure. Diamonds and graphite are both pure carbon but different arrangements. Water's hydrogen bonding gives it unique properties, and metals have electrons that can move freely. Now let's explore the mathematics of atoms and molecules. Chemical formulas tell us exactly what atoms are in a molecule. H2O has 3 atoms. CO2 has 3 atoms. C6H12O6 has 24 atoms. We work with atomic mass measured in atomic mass units, molecular mass which is the sum of atomic masses in a molecule, and molar mass which is the mass of 1 mole of substance. The mole is our special counting unit. 1 mole equals 6.022 times 10 to the 23rd particles, which is Avogadro's number. This huge number lets us count atoms by weighing them. For example, 18 grams of water contains 6.022 times 10 to the 23rd water molecules. While we can't see individual atoms directly, we can explore them through hands-on activities. You can build molecular models with marshmallows and toothpicks to understand structures, observe Brownian motion with food coloring in milk to see molecules moving, demonstrate diffusion with perfume to show gas molecules spreading, collect elements from everyday objects, and play chemical formula games. Modern tools like electron microscopes can actually see individual atoms. Scanning tunneling microscopes can manipulate atoms. X-ray crystallography determines atomic positions, and mass spectrometers identify atoms by mass. In 1989, IBM scientists spelled IBM using just 35 xenon atoms. Congratulations on mastering atoms and molecules, the fundamental building blocks of our universe. We've learned that atoms are the smallest units of elements with protons, neutrons and electrons. Molecules are groups of bonded atoms. Atomic structure has evolved through centuries of discovery. Chemical formulas describe molecular composition, and we can mathematically work with these tiny particles. In our next lesson, we'll dive into chemical symbols and formulas to become fluent in chemistry's language. Remember that you are literally made of stardust. Most atoms in your body were created in stars billions of years ago. Thank you for exploring the microscopic world with Silent Reader Chemistry.